So section 2 is on solving systems by substitution. We're going to learn some algebraic methods to solve systems. Hopefully these look familiar from Algebra 1, and these are much more reliable methods than solving by graphing. So on this page we see a whole list of steps to solve by substitution. If you are a list person, feel free to write all of this down. If you would rather just see it and jot your own notes, that's fine too. But I'll go through the process and then we'll take a look at how it actually works with a system. So the first thing that you want to do is get one of the equations into a y equals or an x equals form. We're not looking at graphing, so an x equals is just as easy to solve by substitution as a y equals. And then you will substitute that solution into the other equation, replacing whichever variable you just solved for. You will end up with one equation with one variable. If you end up with an equation with two variables, you substituted wrong at some point. So you'll solve your one equation with one variable, just like we solve normal equations. And once you have that solution, you'll substitute it back in and solve for your other variable. And then always write your solution as an ordered pair. Thinking back to yesterday, we looked at graphically what a system or a solution looks like. So the ordered pair kind of helps focus your solution as an XY ordered pair. All right, so let's see how this works in real life or in a real application versus all of those words that are kind of vague. So I'm looking at a system where I've got 2x minus y equals 2 and 3x minus 2y equals 11. So I want to get one of the equations solved for x or y, doesn't matter which one. But I also want to do this in a way that's easiest for me. And looking at, for example, our first equation, if I'm solving for x, I'm going to add y and divide everything by 2, which is going to give me a variable. Same thing for my second equation. So you want to find an equation where there is a variable that has a coefficient of 1 or negative 1 already, because then you don't have to divide to solve for that variable, and you won't end up with fractions. So I'm going to actually at the same time add y to the right hand side and subtract 2 over to the left hand side to get 2x minus 2 equals y. So what I do is once I have one variable all by itself, I put what that is equal to in parentheses. And then I'm substituting for y because I have y equals. So in my other equation, I put parentheses around y. I'm replacing y with 2x minus 2 because y equals 2x minus 2. So I'm going to rewrite my second equation with replacing or substituting y with 2x minus 2. Now look at your equation before you start solving. After you substitute, make sure that you only have one variable showing up. The only variable I see is x, so I'm going to go ahead and solve this. I'm going to distribute my negative 2, so be careful that you don't distribute a positive 2, because then you'll make a mistake. Obviously, you won't have that negative carried through. Combining like terms, 3x minus 4x is negative x. Subtracting 4 from both sides and dividing both sides by negative 1, I get x as negative 7. I can take this value and substitute it into either of the original equations or the one that I solved for. The easiest one to substitute it into is the one that I solved for, because if I replace x with negative 7, I already have y alone. So it's just a matter of order of operations. 2 times negative 7 is negative 14, minus 2 is negative 16. And then I always write my ordered pair, x, y, and that's the solution to our system. Alright, and just to keep the classification in the back of your mind, this system is consistent because it has a solution, and independent because it has only one solution. So looking at B, again I notice that this variable has a coefficient of 1, so I'm going to add x and subtract 4 from both sides. Now that I have x solved for, I'm going to put what it's equal to in parentheses, and I'm going to replace x in my second equation. So it becomes 2 times 7y minus 4 because x is equal to 7y minus 4. And be careful that you only replace the x. Don't replace the coefficient, don't replace the minus 3y. And then look at your equation. We have one variable, we have just the y. So I'm going to go ahead and distribute my 2. Combining like terms, 14 minus 3y, adding 8 to both sides, and dividing both sides by 11. Now I need to solve for x. Since x is already solved for in my red equation, I'm going to go ahead, substitute 2 for y. And again, it's just a matter of multiplying and subtracting. 7 times 2 is 14, minus 4 is 10. So my solution is 10, 2.